Here's a few remarks on big data processing from the vendors, cloud vendors. Here's a typical application scenario from Jeff Hammerbacher of Berkeley from his nice data science class, showing how you have a data warehouse with business intelligence and analytics generated from that. There are also products generated from that. And this is in real time generated from the application database. Here we have some remarks from Teradata on the typical business applications, web data, auto insurance. An interesting application here, all the monitors in your car. The auto insurance industry can, in principle, send all that stuff to a cloud, run some analytics program, and give you a rating as to how well you're driving. And based on that rating, you could possibly set your insurance rates. That might be a good or bad thing. There's lots of importance of text data to find out from emails and things like that, and Twitters and things like that. Information about customers. Try to find things that are important across users. There's a nice example in an eBay talk about how they examined how people looked at a particular lamp, and they found out how people misspelt it, and they put in a lot of robustness into the query for that particular lamp. So looking at what people do, and you can see how you can actually improve the interface for other people. There's a lot of importance of GPS data sent to the cloud, and that's sort of similar to RFID, the way you label products. Well, the smart grid is an important source of application data. That means that your entire electrical grid will have meters and monitors all throughout it, and those will be sent back to the cloud to study power usage and also dynamically do power optimization. If you go to Las Vegas, maybe they will be using automatic RFID tracking of chips, which will allow them to detect fraud and identify patterns. Maybe you don't like that one as well. There's the example I've given of the General Electric engine, which GE says it generates far more data every day than Twitter does. And then those engine data are fed into the cloud and then analyzed to look for preemptive maintenance type issues. In video games, you can monitor the user interaction with the games and use that to design better games. And the linkage between people can help telecommunication industries to find new customers and to design better services. And this particular book identifies the key technologies here: parallel computing, clouds, grids, MapReduce, and also the fact that you do want us in the Humbucker example to do your analytics in a standalone environment. So when people study big data, there are lots of V's. Here we have any variety, velocity, and volume. But I think verification and things like that, maybe visualization, these are all different V's associated with data. And obviously, big data platforms are a large commercial application. This comes from a good talk from IBM describing some of the work that big company is doing. And they have obviously a platform with Hadoop optimized, very good NoSQL storage, so that they have optimized data access, and they do machine learning, text analytics. These are all classic big data applications, many of which we've actually gone through in this particular course. Here's more details on their actual platform. Here we have their Hadoop system. Stream computing is for the applications with stream data. They tend to be different algorithms, because if you have a set of data, then you add new data, then you need special algorithms to add new data and understand that implications. We have context. Remember things like you have actual data, and then you have context, such as the nature of the users, which tells you the best way to look at that data. Then we have lots of integration and governance issues and accelerators to make them run fast. And so these are very typical complex systems. Here's more on the capabilities of these systems and what they have. They have the interface, say, with the statistics language R, so they can bring a lot of text. I'm sorry, not text, data analytics, which a lot of the statistics algorithms are written in R, and this is so they have these platforms, and of course, the benefit for business is that the businesses will analyze that data and get results, giving them advantages, because we've studied that in many cases already. And they have these specialized analytics appliances, and appliances are dedicated image, which has built-in capabilities. Here it's data analytics. And obviously with an appliance, you just take your appliance and put it on your laptop, put it on your cloud, and run your application. Here is the same type of thing from Oracle. I mean, these pictures are going over quite fast because all they are is a collection of words. But the words are not trivial. It's just that the devil is in the details. And this tells you all the things you have to worry about if you're employed by IBM or Oracle to build a viable system. And here's nice little graph telling you all the types of data you need. You need big data or master data, transaction data, like checking account transactions, reference data, analytical data, metadata, which is data on data describing the nature of the data sets and things like that, unstructured and structured data. And here's how eBay does all its work. eBay obviously is one of the companies that does lots of data-oriented transactions to support their online auctions and things like that. And here's a comment from eBay on the types of technology you use. It uses Hadoop for general purpose MapReduce. It uses HBase for more structured, semi-structured cases where it has data that fits the big table format. It has a more classic SQL type solution from Teradata. It uses Cassandra, which is an alternative to HBase, and MongoDB, and is a recent version of Cassandra, which has relative smaller data and flexible use of table type data. So these are all, I mean, if you look at a modern cloud system, it has a lot of technologies, and all of these have to be supported. And so that's the end of this very brief overview of clouds. This is a rapidly changing area, and the capabilities on these clouds are expanding every day. Thank you very much.